In this video, we use our skills of finding x-intercepts, graphing parabolas, and solving inequalities to solve something kind of new but kind of familiar, quadratic inequalities. Let's get started. To begin, I want to show you a couple of different versions of interpreting the same picture. So if you would mind, look at the right side of your screen, and you'll see two parabolas, right? They're the same parabola. In fact, they both have the same equation, x squared minus 4x plus 3. So if we were given that situation, we have x squared minus 4x plus 3. Hopefully we would recognize that that's our quadratic model. It's a parabola opening up because our leading coefficient is positive 1. And we could also draw a sketch of the parabola by finding the vertex if we were interested in the maximum or the minimum, in this case the minimum, right, because it's opening up. We could also find the x-intercepts, couldn't we? So to find x-intercepts, we normally let y equal 0. So if we were to let y equal 0 here, we would have x squared minus 4x plus 3 equals 0. And just like we did in our previous videos, when we reviewed how to solve quadratic equations, we could either factor, quadratic formula, complete the square, all of those work, right? So in this case, factoring is possible. You can see that they've already done it for you in the slide. Factors of 3, which add up to negative 4, would be x minus 3 and x minus 1 in either order. And then you could set each factor equal to 0 so that either x equals 3 or x equals 1 would be your two x-intercepts. So if you know that your parabola opens up because its leading coefficient was positive, and the x-intercepts are at 1 and 3, that's how they get these sketches, right? They get their x-intercepts at 1 and 3. Now, as far as the vertex, you could use the vertex formula like we practiced in our last two videos, h being negative b over 2a, k being the output at that input. But all we really need is a sketch to answer an inequality. So once we do our basic sketch of a parabola opening up, going through those two x-intercepts, this is the picture we have. Now notice the two different questions that they're asking us here. In the first question, they're saying, when is this function greater than 0? So what does greater than 0 mean? Not negative, right? Bigger than 0. So when are your outputs positive? When are they bigger than 0? Well, we can see that that happens to the left of 1, but also to the right of 3. That's when our outputs are bigger than 0. In other words, above our x-axis. So when we're asked to find out when we're above the x-axis, we can simply look for that on the graph, right? When I have input values to the left of 1 and to the right of 3. So to the left of 1 or to the right of 3. Now, how would we write that in interval notation? Negative infinity, that's right, until 1. We'd use parentheses since we're not including the actual x-intercept because that would equal 0, not be greater than 0. Or values which are bigger than 3, so 3 toward infinity. Again, parentheses because we don't want to be on the x-axis but above it. So that would be our solution for the inequality being greater than 0. On the other hand, what about the second way of looking at the problem, right? When they ask you for when would this equation be less than 0? Well, less than 0 would be negative, wouldn't it? In other words, outputs which are below the x-axis. So below the x-axis would include all the inputs between 1 and 3. In other words, 1, 3. And they've said that in set builder notation as well. Now, would I use parentheses or would I use brackets there? Well, I'm not including it, so I would use parentheses. I'm not actually on the x-axis. When would I use brackets? Do you know? That's right. If instead of simply greater or less than, we saw greater than or equal to or less than or equal to. Okay, so with that example in mind, once you have the picture of the parabolic trajectory, you can easily figure out when your inputs are negative or positive, right? And then answer the question. So that's the approach I'm going to recommend. Figure out what the parabola looks like using x-intercepts and how it's opening. I didn't even take the time, did I, to find the vertex. It was helpful for other problems like maximizing and minimizing in our previous video, but it's not necessary if you just want to know when are my outputs negative or positive. So that will be my first step. There are other methods. The analytic approach would simply use a number line and use test points to determine when you get negative or positive values, but you'd still have to find the x-intercepts. So in my experience, and my recommendation for those of you who plan to be successful going forward is to always make yourself graph it so that you are very, very competent and confident with graphing and understanding the graph. So let's take a look at how we summarize this on our next slide. Example 1, it says, okay, well, how would you solve this inequality? F of x has to be less than or equal to 0 for the graph f of x below. Use interval notation. So it might be hard for you to see the actual tick marks here. You're welcome to click on the Desmos graph. It's a little clearer. But since I see that there's 5 tick marks when I get to 10, each tick mark must be worth 2. So this must be an x-intercept of 2. And then the other x-intercept looks like it's between -2 and -4. So we're going to say that's at -3. And you're welcome again to look at the Desmos graph provided to see that more clearly, because this graph's a little hard to read. So if I've given you the 2 x-intercepts and I've shown you how the graph opens, could you answer the question? So what is the question here? When is the function less than or equal to 0? So when are your outputs either negative or 0? Can you answer it? Feel free to pause it and see how you do. Yeah, they're definitely negative down here, aren't they? Between the 2 x-intercepts. So if you would have told me between -3 and 2, you'd be correct. But we also were given the or equal to 0 as an option. So we are allowed to actually have outputs of 0, which happen at the x-intercepts themselves. So if we're including them, that's why I closed them up with the circles there, we would use brackets, wouldn't we? So this would be our solution in interval notation, bracket -3, 2. So again, when I'm giving you the graph, I hope you can answer these questions. But unfortunately, in my in-class experiences for testing, I've seen many students skip these questions because they don't know what it's asking. So make sure you practice enough so you know what this is saying. It's saying, when are my outputs, in other words, my y values, negative or 0? That's what it's saying. In other words, on or below the x-axis. Okay. So let's go to our next slide where we summarize everything and then look at not the graphs, but the inequality itself. Here we go. Solving inequalities graphically can be done in this nice 3-step process. So if you like steps, I'm all about them. Here we go. Suppose we're giving you an inequality like x squared minus 8x is greater than or equal to -7. So to begin, the first thing we wanted to do is to be able to figure out the function so that we can graph it and then answer the question of when we're above or below the x-axis. So how do we know what the function is? First step, get 0 on the right side. Now you might be thinking, why does it matter what side I get it on? Technically, either side is correct, but to interpret the results correctly, I find that 9 times out of 10, my students do much better if 0 is on the right side. They interpret what's happening in the correct way. So let's go ahead and do that. To get 0 on the right side, what would you get here? Yep, x squared minus 8x must be greater than or equal to -7. But if you move the -7 to the other side, you'd have to do what? That's right, you'd have to add 7. So now you have +7 on the left side, greater than or equal to just 0. That's step 1, get 0 on the right. Now that we've done that, we know what function we're graphing, right? We are supposed to be graphing the function x squared minus 8x plus 7. Now in this course, we're only going to give you very nice functions which you can factor. In reality, you would have to use the quadratic formula or complete the square to find your x-intercepts. And that's what we're going to be finding in step 2. In order to graph the function, which is what we're going to do in a moment, we're going to use intercepts. If you want to use the vertex, more power to you, but the intercepts are the bare minimum. So to do that, let's see if we can remember how to factor here. Feel free to pause the video and test your factoring skills. All right, when you find the factors of 7, which add up to -8, you would have x minus 7 and x minus 1. So same sign, both negative, because -7 times -1 is +7, and -7x plus a -1x is -8x. Okay, so make sure you take the time to factor correctly and check yourself by foiling. Once you've done the factoring, you can answer the question, what are your x-intercepts? Well, by letting each of those factors equal 0, the only time x minus 7 would equal 0 is if x were equal to what? 7. And the only time x minus 1 would equal 0 is if x was equal to 1. Good job, setting each factor equal to 0 to find your x-intercepts. On the graph then, at 1, I know I have an x-intercept, and also at 7. So 1, 2, 3, 4, 5, 6, and 7. Okay, we also know how the parabola opens, because our leading coefficient was, that's right, positive. Since your leading coefficient was a positive, we have a graph that is going something like this. If you want to find the vertex perfectly, you can use your vertex formula, but at the bare minimum, you have a sketch that looks something parabolic in nature. Okay, you also know that you could find a y-intercept if you wanted a better sketch, and you could use the axis of symmetry to get a more perfected sketch. But all you needed is a basic sketch, using x-intercepts and how it opens. Okay, we have the graph, we're ready to answer the question. So don't stop there, otherwise you've done all this work, but you haven't answered the question. Okay, so what is the question, you might be wondering? The question, of course, here is, in step 3, we are asked to determine when the outputs are going to be negative, positive, or 0. So let's see what they're actually saying here. They're wanting to know when would our function be greater than or equal to 0. So step 3 here, interpreting that correctly is key. Greater than 0 means above the x-axis, but equal to 0 means on the x-axis. So they're really saying when are our outputs above or on the x-axis? Well, they're on the x-axis at those x-intercepts of 1 and 7, right? And they're above to the left of 1 and to the right of 7. So how did you write your answer? Can you go ahead and write it down for yourself? See how you did? What would your solution have been? Yeah, values left of 1, but including 1, since it was equal to 0, right? So negative infinity to 1 itself with a bracket, union, what? That's right, 7 to infinity. So if you said negative infinity to 1 with bracket, union bracket 7 toward infinity, you were correct. Well done. All right, we have a couple more to practice, but there's nothing new for the rest of the video. So feel free to go as fast or as slow as you like to make sure that you understand how to solve these inequalities. Here we go. Example 2 says, solve the inequality x squared plus 3x is greater than 10. Write the solution in interval notation. Okay, again, feel free to pause the video, try it on your own. The first thing I would do in step 1 is get 0 on one side. So that means x squared plus 3x minus 10, when I subtract it, is greater than 0. Okay, what was step 2 again? That's right, we want to get the x-intercepts so that we can graph. And they're going to give us nice things that factor. Otherwise, to find these x-intercepts, what would you have to do? Use the quadratic formula, that's right. So you could do it that way every time for practice if you really want to. Okay, so we'd have x and x. What factors of negative 10 with different signs end up with a difference of 3? That would be a 5 and a 2 with different signs. The bigger number would be a 5, and the smaller number would be the negative 2. So if those are your two factors that we have to make greater than 0, the x-intercepts would be negative 5 and 2. Okay, so let's go to our graph and show what this graph might look like. 1, 2, 3, 4, 5 to the left, and 2 to the right of the origin. How does this parabola open, up or down? That's right, it opens up because your leading coefficient in either case was positive. That's why it's opening up. So you could have a sketch that looks something like this. Of course, the vertex you could find using the vertex formula, and the y-intercept you could find by letting x equal 0. But for a basic sketch, this would suffice. Something like this is going on. Let's take a look at our last question. What are we really asked to find, right? They want to know when our outputs will be positive. When are they greater than 0? In other words, when are they above the x-axis? Well, can you see? Yeah, they're above the x-axis. It looks like values to the left of this x-intercept and values to the right of this x-intercept. This x-intercept on the left was negative 5, and this one was positive 2. So how did you write your answer? What was your solution? Was it negative infinity to negative 5 with parentheses, union parentheses 2 toward infinity? I hope so. Again, why did I use parentheses instead of brackets this time? That's right, because I didn't include the option of outputs of 0. They were strictly greater than 0. All right, we have one more question, and it might be a little confusing, so take your time with it. Feel free to use the Desmos link provided, and then check yourself with my solution. Okay, so let's take a look at example 3. Example 3 says, solve the inequality using interval notation. This time it looks a little funky at first. 2 parentheses, 2x squared minus 3x is greater than or equal to negative 9. One thing that looks a little bit different than the previous ones is that we have parentheses here, right? So we have to expand first. I'm sure many of you thought of that already. So what did you get after expanding, after distributing here? That's right, you got 4x squared and negative 6x, well done, is greater than or equal to negative 9. So after you distributed, go through your 3-step process again. What is the first thing I do? What is the second thing I do? And how do I answer the question? See how you're doing here. Okay, so the first thing you did, if you remember correctly, was get 0 on one side. So you got 4x squared minus 6x plus 9 must be greater than or equal to 0. Okay. Now this might have caused a little bit of anxiety for some of you who haven't factored in a long time. Trinomials where you have leading coefficients other than 1. But when we have leading coefficients other than 1, you could either use what we called the AC grouping method, where you multiplied A times C, 4 times 9 is 36, and then you found the factors of 36 that added up to B, which was negative 6. then you split the baby, if you will. You split that negative 6x term into those two pieces and factor by grouping. That's an option that takes a lot of time, but it can be done. So if you want to look that up, there are lots of videos out there. It's called the AC grouping method for factoring. Another option was trial and error, which you may have tried. You may have said, okay, 2x and 2x, 3 and 3 were the factors that would give you the 4x squared and the 9. But the problem is here, none of your options are working. Okay, so if you've tried factoring for a few minutes and you're feeling frustrated, it could be that you made a mistake, but it could also be that this doesn't factor. So if it doesn't factor correctly, what was my other option? Well, I could begin the quadratic formula. That's an option. So if you started the quadratic formula, the reason it might not factor is because it might have irrational x-intercepts, like square roots. That could be the issue here. Okay, or there could be no x-intercepts. So let's go ahead and look at the quadratic formula, either the entire thing or at least the discriminant, and we'll take a look at what's going on here. The quadratic formula said x equals, remember that song, negative b, negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you haven't memorized that, you can always go on YouTube, and there's the Pop Goes the Weasel song. I think there's rap videos. There are lots of ways to learn the quadratic formula. So if you haven't learned it correctly, make sure you take the time to do that. Okay, once you have the quadratic formula ready, now you have to plug it in, right? So let's do that. We would say the opposite of b would be negative 6. Well, that's just positive 6, isn't it? Okay, plus or minus the square root of b squared. Negative 6 squared is just positive 36. Minus 4 copies of a times c, 4 copies of a is 4, c is 9. Well, notice what's happening under there. 2 copies of a in the denominator is just 2 times 4, okay. Look what's happening under the radical. That's called the discriminant. You have 36 minus 4 copies of 36, because 4 times 9 is 36. So if you have a positive 36 minus 4 copies of 36, you're going to end up with negative 3 copies of 36. In other words, a negative result. And if you remember from your previous math experiences, when we studied quadratic equations, if you got a negative under a square root, that was imaginary, meaning that there are no such solutions to this equation. What does that mean for us? There are no x-intercepts. So it doesn't always happen that if it doesn't factor, there are no x-intercepts. It could be that they're just irrational. But in this case, by using the quadratic formula, I could tell there are no x-intercepts. Now, does that make sense? Could a parabola have no x-intercepts? Well, yeah. We've talked about parabolas which open up before. They can look like this, where they have 2 x-intercepts. They can look like this, where they have 1 x-intercept at the vertex. Or they could even look like this, where your graph is completely above the x-axis, right? All 3 of those are possible, where you have the 2 x-intercepts, the 1 x-intercept, or no x-intercepts. What we're claiming here is by using the quadratic formula and getting an imaginary number under a square root, right? A negative number under a square root, which is imaginary, we have no x-intercepts. To confirm this, if you were a little nervous on a test question, for example, is this right? This seems strange. What is the vertex? Feel free to find the vertex. If you went through the process of finding that vertex, it would be at 3/4 and 6.75, or 6 3/4. So it would be somewhere here and up around here somewhere. So this graph is looking something like this. So once you have an idea of the fact that there are no x-intercepts and the graph opened up, that must be saying that your graph is always above the x-axis. So now we can answer the question once we understand where the graph is, right? It's always above the x-axis. Okay. The question was, in step 3 here, the question was, when is my function greater than or equal to 0? In other words, when is my function above or on my x-axis? Well, it's above it always, right? It's always above it because its vertex was way up yonder at 3/4. This was at 3/4 and 6 3/4. You're welcome to check that using your vertex formula from the previous couple videos. So that's that location there, okay? So because you're way up yonder and it's opening up, you're going to always be above the x-axis. When are you on it? Never, but it's an or situation. Are you ever above it or on it? Well, yes, we're always above it. We're never on it. So the solution would be all inputs would make it above the x-axis, would give you positive outputs. So the solution is negative infinity to infinity. So if that was what you were thinking, probably not. You were probably a little confused. But if that was what you were thinking, you would have been correct. Now notice, if the inequality arrow had been flipped, if it had been less than 0 or less than or equal to 0, well, you never have negative outputs, do you? So that would have been no solution. Okay, so there are times where you'll get all inputs that would give you these outputs, or none of those inputs would give you these outputs. They're both valid options. So sometimes that happens. It doesn't necessarily mean you made a mistake, but it's a good idea to go back and check your work, check Desmos, check your vertex to confirm your suspicions that there are, in fact, all real numbers working as solutions. Okay, so you've now seen in this video how to solve quadratic inequalities by getting 0 on one side, by then finding x-intercepts, drawing a graph, and answering the question about your outputs being positive or negative. I hope you practice because math is not a spectator sport, and I'll see you next time.